Hello everyone, my name is Chris Chen. I'm the CTO of Issues Technology. Welcome to my channel. So in today's video, I'm going to show you our new vacuum tube tester designed for testing small signal tubes like 12X7 or 12AU7 or a 6SN7. Okay. So I've been working on this project for more than 2 years, so I spent a lot of time on this project. The design goal for this project is to come up with a vacuum tube tester that has the following properties. The first one is a constant voltage and continuous current power supplies. So it means the device under test is always powered on the plate. So there are many comments on each tester for not being a tube tester that supply power continuously. So for this small signal tube tester, I decided to provide a constant voltage, continuous power supply. The second goal for this project is I want a tube tester that's compact and lightweight. So this tester has two print circuit board stacked, and each print circuit board is 20 centimeter wide, 14 centimeter wide and depth, and when they are stacked, they're a total of 6 centimeter tall, as you can see in this photo. Then the third design goal is to have a tester that's to make it a standalone tester, so it doesn't need any unlike each tester, it doesn't need any PC to operate. So it comes with all the knobs, buttons, so we can test the tube by itself. The number 4 goal is PC connectivity. So although it's a standalone model, I found it's cumbersome to edit the tube tester, the parameters for each tube. So a better way to do that is we edit all the tubes configuration files on a PC, then download it to the tester by the USB port. The number 5 goal is I want to make this machine state of the art. It's one of a kind. I want to use the cutting edge technologies to make it small, compact, and it will be the best in class product. Okay, so next, we are going to talk about the design spec. So for the power supply, this tester can provide 50 volt to 50 volt power at 40 milliamp continuously, and for voltage below 250 volt, it can supply up to 50 milliamp current continuously, and the maximum output power will be 15 watts. And it's a switching mode voltage power supply, so it's very the switching frequency is very high. It's 200 kilohertz, so the noise won't be audible, and it will make the required component much smaller. So the total area for this power supply is like 1 inch by 2 inch, so very small in footprint. Secondly, the grid voltage supply can supply a voltage from 0 to minus 15 volts, so it's sufficient for testing small signal tubes. And it also has a 442 hertz sinusoidal waveform generator, so we can listen to hear the output of the device under test by the integrated speaker. Okay, and the this tester also has a innovative configurable constant current source. So this is I think it's never done before. It's I've spent a lot of time on this circuit. I pretty much I at least redesigned this part of the circuit for more than 5 times. So this configurable constant current is floating, so it can be connected on the high side, aka the plate side of the device under test. So it can it can be configured to provide a constant current from 0.5 milliamp to all the way up to 50 milliamp. And a nice thing about this constant current supply is it also has inherently has a short circuit protection, because when we configure the current, any current goes above the configured current will be limited. Okay, and this tester has the ability to allows the user to select which section to test. We know a lot of small signal tubes are twin triodes, so it has 2 sections inside one envelope. So we have a switch that allows the user to select which section to select, or we can or there's a position that we allow the user to connect the both sections in parallel, so we can test it as one unit. And this machine comes with a vibration motor, and the power supply of this vibration motor can be adjusted from 2 volt DC to 60 volts to 6 volt. So this way we can control the how powerful the vibration motor will be. And this vibration motor will be used for microphonic test. It will be a source of shock, and we can monitor the effect of the shock to the output of the amplifier signal. And this machine comes with a 1.5 volt to 27 volt heater power supply, and the rated current is 2A. So the reason for 2A, we know in each tracer the power rate, the current rating is 3A, the heater supply, and it comes with a heatsink. But for this project, we don't really need a heatsink because most of the tubes we're going to test has very low power rating. For example, for a 12X7, it's the heater supply spec is 12.6 volt, and the reference current is 150 milliamp. And we need 2A because we can use this tester to test very early tubes like 26 or 27. Those tubes are designed to be operated on a battery, so the voltage rating is relatively low, like 1.5 volt, so the rated current would be much higher. Okay, and this machine comes with a audio amplifier. It's a very small audio amplifier, and it has an integrated speaker. So if there because we have a waveform generator, so we can actually listen. We can actually hear the output of the vacuum tube under test. And this machine also comes with a BNC output, so we can monitor the play signal if the user wants. Okay, so as we can see, this system is very compact. And this is a vibrating motor. This is a speaker. We have the BNC output. This is a volume control for the speaker. We have the DUT selection, the test mode selection. This is a knob that we can select which section to be tested, or both, or none. And we have this, I think this is a heater adjustment, vibration voltage adjustment, and negative. This is high voltage adjustment, and this is a negative volt on the green volt adjustment, and this is the encoder, so we can adjust the values. And on these 4 buttons are for this one is for heater on off switch, this one is high voltage on off switch, this is vibrator on off switch, and this guy is a test button. Okay, and this is the 2.8 inch IPS LCD screen, so it has a very wide viewing angle. It's very bright. Okay, now we can have a look at this system architecture. So this is the system architecture, and this figure shows how the DUT is connected. And the DUT in this diagram is a 6C45. So on the heater side, we have a 1.5 volt to 27 volt power supply at the rated current of maximum output current of 2 amp. And this 0.1 ohms resistor is a current sensing resistance. So if we actually have a voltmeter connected across this resistor, so it will give us the current reading of the heater supply. Okay, on the plate, we have a constant high side current source. Oh, I forgot to mention the current source is ideally has a very high internal, ideally infinite internal resistance. So it's a very good device as a plate load instead of using fixed resistors, because if we use fixed resistors as a plate load, it will consume we need a lot of voltage drop and it will consume a lot of power. So here we have this configurable constant current source connected on the plate of this DUT, device under test, and we have amperometer. So this current source it's not only a current source, it also provides the current reading. And here we have this 50 volt to 350 volt 40 milliamp high voltage power supply connected on top of the current source. On the grid, we have a sinusoidal generator, a waveform generator, 442 hertz, and we have a 0 volt to minus 50 volt grid bias supply. So this is a like simplified diagram. Like it's more like a block diagram. So the actual circuit is much more complicated than this. So we combine both signal together, and we send the combined signal to the grid through either a 1K resistor or a 180K resistor. So these two resistors will be used for gas test. So if for gas test, if we connect the output of the grid voltage, the grid driver through different resistor, and if there is any grid current, we can derive the grid current by measuring the difference across the resistor. On the plate, we have a voltmeter. It's actually a ADC, analog to digital converter, so we can monitor the plate voltage in real time. At the output, we have a capacitor that remove all the DC components, so we can amplify the signal. So if we connect a sine wave sinusoidal signal here, we can actually hear the signal output sent to this internal speaker. And also we have a buffers, and we send the plate signal to the BNC connector. And okay, so this is a BNC connector here. Okay, so this is pretty much this will give you a general idea of how this machine is operated. Okay, now next we are going to talk about the test mode the machine can do. So the first test mode is voltage based voltage parameter extraction. So this test mode is more like the traditional way to extract magnitude parameters like GM, mu, and RP. So the idea is we supply a fixed plate voltage and this fixed negative grid voltage. Then we track two parameters at this question operating point. The nice thing about this tester is it can extract parameters at arbitrary question operating point, not unlike other like the TV7, the old tube tester, the question point is always fixed. Okay, so we have the full control over which question operating point we choose, and based on that operating point, we can extract the parameters. The second test mode is the world's first implementation. It's never done before, and this idea came from the discussion I had with the owner of Jack Music, Jack from Dave Wallace, the owner of Emission Labs. He insists that the parameters for a tube should be extracted from the the specified plate current instead of the fixed bias like the voltage based extraction. And I'm not totally agree with his idea because if a tube is very weak and the only way to boost the plate current is to reduce the negative grid voltage. So even we at that operating point we extract good numbers like a higher GM, lower RP. We're going to lose a lot of voltage swing because if we make the grid bias less negative, we are going to lose the voltage swing on one side. Okay, so the current-based parameters extraction is the worst first implementation. So it extract two parameters at the specific question plate current and specific plate voltage. So we specify the plate voltage, we specify the plate current, and it's easy to do because we have a current source. We just set the current source there, and then we can tweak, we can change the grid bias until we hit a specific plate voltage. So that gives us the question point. At that point, then we can extract the parameters. So the extracted parameters will be grid bias, the GN, the mu, and the RP. The third test mode is gas test. So gas test mode, it's like TV7. So like I described in my previous in this photo. So we basically perform two measurements through the two different values of resistors. Then we check. We can derive the grid the grid current, and we can measure the plate current difference. And the difference between this machine and the TV7 is like this machine allows arbitrary question operating point. Like old test mode, you can set whatever question operating point you want, and then you perform a gas test there. So the grid current is derived by calculating the measure the grid voltage difference, like I described, between two resistor values. Okay, the next test mode is microphonics. So in this mode, the constant current source will be connected to the plate electrode of the DUT as a plate load. Okay, and we have a graphic sound level meter. Let me this guy here is a sound level meter in dB. So microphonics can be observed by tapping the DUT. So we can the old method is you can use a pen or pencil to tap the the device under test, or we can just use the vibration motor. A nice thing about the vibration motor is it gives you a more consistent shock to the device under test. If we tap the device, if we just tap the tube, sometimes we tap it harder. Sometimes we cannot control the force to provide the consistent force at each run. So by using the vibration motor, it more or less gives more consistent read of shock. So we can compare different tubes more in a more fair way. And it also has a 442 hertz sinusoidal voltage source, so the system can check the amplification factor in real time. And at the BNC output, like I said, we can observe the plate waveform on a oscilloscope, and it also has an internal speaker for sound monitoring. Okay, number 5, PC connectivity. So, like I described, the tubes configuration files is managed by the PC software, so and downloaded to the mini tester's flash memory. So this is a standalone. Again, this is a standalone machine, but all the chore can be done at a more user-friendly environment on a PC. And the second bullet, curve tracing. This machine, by nature, can do curve tracing, but if it's needed, I'm not sure yet. So it's to be decided. Okay, so here are all the pretty much the features of this new tube tester. I'll do a separate video for a real-time demo, but I need to set up the camera so we can have a better look. Better view of the machine, and so now I'm just going to go give you idea of what's we are offering for this mini tube tester, and I'll design the chassis for it next week, and I'll bring this machine to the high-end show in Munich. In Germany this May. Okay, so I'll see you next time. Bye bye.